So let's talk in this video about the graphs of our exponential functions. We can have an exponential function represented in two different forms. The first one over here on the left shows my exponential function increasing. This is growing rapidly, and an example of this is something like money, interest rate, something like that. This function here that is increasing is represented with a base of 2. Here on the right picture, we have a function that's decreasing. Notice it is falling quickly. An example of something like this might be decay or half-life from chemistry or biology or something. It is represented by a function with a base of 1/2. So the base of the function is going to determine the increasing versus decreasing that I see here. Let's kind of summarize those characteristics of our exponential functions in this way. So if I have my exponential function base a raised to the power of x, on the leftmost picture here you have an increasing function. This characteristic is increasing when my base a is greater than 1. So anytime the base is greater than 1, this is what the picture will look like. I have an horizontal asymptote at y is equal to 0. I have a y-intercept occurring at 0, 1. And then it may be necessary to understand what these 2 points are on either side of my intercept, which you can see here. They come from the base a, and you can write those down. Now over here on this picture you see I have a decreasing function. This is when the base a is between 0 and 1. So if it's a fraction or a decimal value raised to an exponent, then this is what the picture looks like. Notice, however, that the horizontal asymptote is still y is equal to 0. My y-intercept is still at 0, 1. It's just the shape of my function has changed, and therefore the points on either side of that intercept have changed as well. For both of these functions, since they are both exponential functions, the domain and the range of the function would be from negative to positive infinity for the domain, so all possible x values, and then the range, which talks about the y values, would be from 0 to infinity. Again, we already said that both functions, or both characteristics, or both increasing and decreasing, I want to say, have an asymptote at y is equal to 0 with an intercept at 0, 1. So the shape of the function, increasing versus decreasing, comes from the value of a. And the last thing that you want to understand, and it's important for the very next section, is that these functions are indeed one-to-one. Now, let's talk about how to graph our exponential function. We're going to do it using transformations. Recall from a previous lesson or several lessons ago that we can graph functions by using transformations, or in other words, shifting the function left, right, up, down, and so forth. So I kind of gave you a summary of those translations right here. And we have vertical translations which shift up and down, horizontal translations which shift left or right. We have reflections which we can either reflect across the x-axis or maybe the y-axis. Then we have vertical and horizontal stretching and shrinking, and these two are probably the hardest. I did put a note in here for when you're doing a vertical stretch, you're going to end up multiplying the y-coordinate of an ordered pair by whatever that c is, or c is what we have. And then if you have your horizontal stretch or shrink, you divide the x-coordinate by c. So I wrote that in the notes. I would make sure that you had that available as you went through the homework in the notes. So how do we graph this function? We're going to start out with f of x is equal to 5 to the x plus 1. The first thing that I want to be able to identify in this function is whether or not it's increasing or decreasing. And that comes from identifying the base a. So a in this case is equal to 5. We know that 5 is greater than 1, and therefore the function is an increasing function. So I get an idea of what the shape of it is going to be. I know that this function is going to cross the y-intercept at 0, 1. That should be 0, 1. And I know that it has a horizontal asymptote at y is equal to 0. That's what I know about a function with a base of 5. Before I ever shift it. Now let's talk about what the x plus 1 does to it. x plus 1 is inside of the function. When that's the case, we have a horizontal shift. We shift left or right based on this number right here, and we shift opposite of what we see. So we're actually going to be shifting to the left, which I wrote already. We shift to the left by 1. We also know, I'm going to go back up here, I also know that my original function, just to make it a little bit cleaner on our notes, I know that to the right of this point we have the point 1, 5, and to the left of it I have negative 1, 1 over 5. Where did these 2 points come from? They came from this idea here. So to the left of my intercept it's 1 over a, to the right of my intercept it's just a, and that's what I wrote here. Okay, so now we can kind of come over here and we can use translations to graph the function. Since I have a shift left or right, the horizontal asymptote is not going to change, right? Correct. So I'm going to put that in here first. So I have a horizontal asymptote still at y is equal to 0. Now this point 0, 1, that's usually where I start. 0, 1 is the intercept, but because I'm shifting to the left by 1, it now has shifted here by 1. This other point I have at 1, 5. So if I move over 1 up 5, that's where I start originally, but now I shift, so I'm here at 0, 5. And the last point is here at negative 1, 1/5. So I started at negative 1, 1/5, which is really down low, and I shift to the left by 1, and so I'm somewhere down here. It doesn't have to be perfect. So these are the points that I'm going to use now to draw my function like this. That's about all we need, and that's how we graph it using translations. Let's try one that's a little bit more difficult. Here we have the function e to the 2x plus 1. First, I want to identify what its shape is so I understand if it's increasing versus decreasing. The base a is equal to e. Remember that e is represented by the number 2.7, so I know that 2.7 is greater than 1, and I again have an increasing function. I know that for an increasing function or an exponential function, no matter what, I have a y-intercept at 0, 1, a horizontal asymptote at y is equal to 0. Now let's identify what kind of shifts we have. Here I have the number 2 being multiplied by the exponent, so I'm multiplying inside of the function. That right there tells me that I'm going to have some sort of stretch or shrink. And then the plus 1 tells me that I'm going to have a vertical shift by 1. Now let's go back and refer to that table that I told you I printed. If you look right here, we have a horizontal stretch or shrink occurring because the number 2 is being multiplied by my exponent. And what we said was if that's the case, then I'm going to divide my x-coordinate by c. How do I handle that? Well, let's just make a few notes first. The 2x is going to tell me that I am going to divide my x-coordinate by 2. The next shift or translation we have is the plus 1. So a plus 1 means that I am going to shift vertically up by 1. I'm going to handle this one a little bit differently, and it's mainly because of this shrink that I have going on, and it kind of makes the whole problem a little bit more difficult. So in order to keep everything straight, I'm going to come down here and I'm going to kind of create a sort of table to keep up with everything. I know that I have a parent function e to the x. Before I ever do anything to it, I have a function e to the x. The next translation I have is e to the 2x when I have the multiplier. Then finally I have e to the 2x plus 1. Those are the 3 cases that I have going on. When I have my parent function e to the x, I have 3 points. Remember, we have negative 1, 1 over e. I have 0, 1, and I have 1 e. Those are the 3 points that I know from the parent function. Now, if we're moving to this next translation, it says that I'm going to divide my x-coordinate by 2. So in the ordered pairs that you see here, I'm going to divide each of the x-coordinates by 2. So I have -1 divided by 2, which is just -1/2, 1e. The 0 divided by 2 is just 0, 1. And finally, 1 divided by 2 is 1/2 e. That's the effect of multiplying by 2. Now finally, I have this last thing that says, well, now that I've already done the e to the 2x, I am going to, and I wrote this wrong, I am going to add 1 to the outside of the function, right? I'm adding 1 to the outside of the function, which means that I have a vertical shift. If I shift vertically up or down, then I'm affecting the y-coordinate of each of these ordered pairs. So for this first pair, the x-coordinate stays the same, but I'm going to add 1 to the y-coordinate. I'm going to do that here for the second pair. X stays the same, but y becomes 2. And for the third, I have 1/2 and e plus 1. Now I can estimate what these values are in this last set of ordered pairs pretty easily in my head, so that's why I left them as they were. Now let's go try to graph this thing. Ultimately, it's this part right here that I'm graphing, right? The e to the 2x plus 1, which can be represented by these 3 points. So I have the first, I'm going to start actually with this intercept, the whole number, it's easiest, 0, 2. This is where I'm crossing the x-axis at 0, 2. Next, I have a point that's represented by 1/2 and e plus 1. Well, let's just kind of guesstimate here. E plus 1. E is 2.7, so 2.7 plus 1 would be approximately 3.7. So I am at now 1/2, 3.7, which is, I don't know, roughly up there. Now let's go back to this one here. I'm at -1/2, and this is 1 over e plus 1. Well, remember e is 2.7, so let's just call this 1/2 plus 1, which would be 3/2, or 1.5. So my next point would be at -1/2, 1.5, a little more than that, we're right there. Now I have my points on here, but the next thing I need to understand is what happened to that asymptote. If my entire function shifted up by 1, then that means that the asymptote also shifted up by 1. So let's sketch that on here as well. I have a horizontal asymptote that shifted up by 1, so we now have a horizontal asymptote at y is equal to 1. And now I can sketch my function, which looks something like that. And that's how we would graph it using translations, transformations. Those mean the same thing. I would say that when we have a multiplier like this and you're graphing it by hand, it's sometimes easier to just kind of lay out your points like this.